Hello and welcome to my channel. So today I have with me this LCD 16 by 2. This is a newly purchased module. Its part number is 1602A. So it is a 16 pin module. It's called 16 by 2 because there are 16 columns and 2 rows in this LCD. So 16 into 2 gives us 32. So we can print 32 characters on this LCD display. I have a blue backlight LCD display, but there's also a yellow backlight one. Both are the same. So I'm going to interface it with the Nuvoton 8-bit microcontroller. In my previous tutorial, I interfaced it with a keypad. In case if you're new to the microcontroller, then watch tutorial 1. It will guide you on how to make the kill setup and write a simple program to blink a LED. But now let's proceed on with this LCD module. So when you first buy this, there is one transparent film on this LCD. Okay, so you have to peel it slowly because if you peel it fast, then the static electricity may damage the liquid crystal. So you have to peel it very slowly. Why I'm doing this? Because it's told in the data sheet. That's why. So you can see, so it has a nice glossy glass on the top. So you have to be careful not to press on this glass. Okay, when you have to fix this on the breadboard or make any connections, you have to hold this part. Don't hold this. So now I will solder the header pins on this pads and come back, and then I will make the connections. I will explain you the pin diagram and the pin functions, then we'll make the connections according to the circuit diagram. So this is the buck strip. You have to purchase this and cut it to 16 pin like this. So I've soldered the header pins on this LCD. Now let's take a look at its pin diagram. So this is the proper way of connecting the LCD. In some circuit diagrams it's shown like this and the characters are printing straight, but it's actually wrong. It's good for drawing the circuit diagram, but actually the LCD is connected like this. So you have to place these pins at the top. That's why I've drawn the pin diagram like this with the pins at the top to avoid confusion. So the first pin on the left hand side is the ground pin. The second pin is the 5 volts. Third pin is the contrast VEE, which needs to be given 0 to 5 volts to adjust the contrast of the characters. Okay. Then the fourth pin is the register select. When it's 0, then the LCD is in the command mode. When it's 1, it's in the data mode. So the data contributes to the actual character that is getting printed on this LCD. The command contributes to the functionality of this LCD, like where the cursor should be, should the LCD clear all the characters and that all things. So when it's in 0, the data will be taken as a command. When it's 1, the data will be taken as a character data. So these are all the commands that we will see later when we write the code, how it affects the LCD. The next pin is the RW pin, read write. So if this pin is given 0, then we are writing to this LCD. So we are using this LCD in our project just to print the data. So whatever data which comes contributes to the character that is getting printed. So we are always using this as an input, not as output. In our project, we have to hard ground this RW pin such that we are always writing to this LCD. The next pin is the enable pin. So giving a low to high pulse on this enable pin will latch this 8-bit data into the registers of this LCD. Then only the data will be effective and be taken as a command or a data. So this 8-bit data will be latched when we give a low to high pulse on this enable pin. It's very important because normally this enable pin must be kept low to avoid garbage data from entering this LCD module. So these are the data lines. So from the 7th pin to the 14th pin are the data line D0 to D7, which must be connected to a port of a microcontroller. So the next two pins are the anode and cathode for the backlight. So you can see there is one LED here. So one LED contributes to the backlight of this entire display. So this LED is internally connected to a resistor of 100 ohms. So you have to give it positive and negative. Anode is positive, cathode is negative. So you have to give it directly 5 volts, or if you find the backlight too bright, you can connect a series resistor, okay, with this anode and cathode supply. So now the pin description is clear. Now let's take a look at the commands. So 0x38 is for the 8-bit mode. Suppose we want to use all the 8 lines to send the data and represent a character, then we use 0x38. So this means that we are using all the 8 data lines. There is also a way where we can use only 4 lines. So that is called 4-bit mode. That we'll see later in this video. So for 4-bit mode, we have to pass the command 0x28. And remember that we have to keep the RS pin 0 in command mode in order for this data to be taken as a command. So the next is 0x01, which is to clear the display. 0x0C is to display on cursor off. That means there is a cursor here which is always blinking. So suppose you want to set the cursor blinking, display on cursor blinking, the command is 0xF0. And if you don't want any cursor, the command is 0x0C. This command is very useful, 0x06 increment cursor, which is also called entry mode. So after giving this command, the characters, whatever they are printing on this LCD, after printing the character, it will cursor is shifted to the next position. That's very important because we want the characters to be printed one after the other. The next is the 0x80, which will set the position. 80 means we are at the top row in the first position. If we write 0x81, then we are shifted to the next position. And 82, again the next position, up till 8F to the 16th position. So that is just for the top row. For the bottom row, it's 0xC0. So starting from here, 0xC0 is here, 0xC1 shifted to the right, 0xC3 again shifted to the right, all up to CF. So in this way you can use these two commands to set the cursor position and to display the characters from wherever you want. The next is this I explained you, 0xF0, display on cursor blinking. So after printing the characters, so the cursor is on the next line because of the entry mode and it's blinking there. So if you want that, it's very useful for the keypad entry, okay, because you want to know where we are typing the character. So suppose you want to make a scrolling characters, then use this command. So the characters are shifted towards the right. 1C is shift left. So all this data we will see when we write a program, and the effects will be seen on the LCD. Now let's take a look at the circuit diagram of this LCD. So this is the complete circuit diagram of the LCD module interfacing with the microcontroller. So the port 2 is connected to the data lines, D0 is connected to 2.0 and D7 is connected to 2.7. Okay, D1 is connected to 2.1, D2 to 2.2 in this way. VSS is connected to ground, VCC is connected to 5 volts, and now how to give 0 to 5 volts to the contrast pin? That's by using a voltage divider network. That's very easy with the potentiometer. Just connect one end of the pot to 5 volts, other end to the ground. The mid shaft acts as a voltage divider, means there you will get a voltage from 0 to 5 volts when we'll move the shaft. So that middle pin is given to the contrast pin. The next is the resistor select, which is given to pin 3.6. Then RW is given ground. Why I told you, because you're always writing to this LCD. Then enable is given to 3.7. D0 to D7, as I told you, connected to port 2. Anode is given to 5 volts. Cathode is given to a resistor. And this is optional. You can also directly give it to the ground, or you can use a resistor between 200 to 1K and connect it to the ground. So yes, these are the connections. Now let's make this on the breadboard. The circuit is made on the breadboard. Now all I have to do is give it power 5 volts, and I have also connected one USB to TTL module. RX goes to TX, TX goes to RX, ground goes to ground. So this is FT232RL that I have used. I connected one USB, other end goes to the COM port. And now I can write a program in KeylID, generate a hex file, and upload this, flash the program in this chip to display a character on this LCD. So let's do that. And then further I'm going to display a string, and I make that string scrolling, the message on the LCD. Then I'm going to tell you how to do it in 4-bit mode so that you can use only 4 wires from the microcontroller to control this LCD. So this is a simple C program to display a single character on LCD. So I'll explain you this code briefly. If you are new to this KeylID, then watch tutorial 1. So the link is given in the description for tutorial 1. So this first line includes all the registers for 8051. Then we define the port and give it a name data. We are putting the 8-bit data on port 2. Then RS pin is connected on 3.6, enable is connected on 3.7. These 4 functions we are using in our code. We are also using void display, but that I will show you later. First we will print only a single character. So void delay is to give delay. It will take a variable t. So if t is 1, the delay is of 1 millisecond. It's a simple nested for loop delay. I have not used timers. Timers we will cover in the next tutorial. The next function is LCD init. When this function is called, it will run all the initial commands before printing the character. And this is LCD command to put command on the port. This is LCD data to put data on the port. So the first function we called in a void main is LCD init, which will pass all these initial commands. So first it will pass 0x38, it will put the LCD in the 8-bit mode as we are using pins from 2.0 to 2.7. Then it will put 0x01 to clear the display so that all the previously stored characters are cleared. Then 0x0f because we want the cursor to blink. Then 0x06, which is entry mode. In entry mode, the cursor is incremented after printing the character. That is important when we have to print a word or just when we have to give some entry from a keypad. Then this is 0x80. So this will set the position of the character. 8 means it is in the first row and 0 means it is in the first column. So it's in the first row and first column. If you want the next column, then you will write here 81. And if you want the next row, then you will write here C. So we want it at the first position, then write here 80. So let's now keep it here 80. And this is the function LCD command, LCD underscore CMD. It will take this unsigned cache CMD. So when this function is called LCD command, this 8-bit data is in the CMD variable. This variable contains 8-bit data which is now put on the port. Then RS is made 0, that means it's in the command mode, and enable is made 1, then a delay is given, then enable is made 0. So when enable is made 1, a high to low pulse is given, then whatever the data is, it's stored in the command register. It's taken as a command by the LCD. So the next function is LCD data. So it's similar to LCD command function. The only difference is here we are making RS is equal to 1. So we put the 8-bit data on the port, then we make RS is equal to 1, then we give a high to low pulse on the enable, which will put the 8-bit data in the data register, and the command is taken as a data, which will contribute to the character. So whenever we call LCD data, we pass the character. So this character is nothing but a hex value, a 8-bit value, which is put on this data, just put on the port 2, then a high to low pulse is given, which will print the character on the LCD. So this is a void delay function which we saw in the blinking LED example in tutorial 1. So I'll not explain this. This is a nested for loop delay. For those who don't know, watch tutorial 1. So yes, this was the complete code. Now I will build the code, generate hex file, and upload it using this Nuvoton ISP facility. As you can see that the code is uploaded and A is getting printed. A is printed, now the cursor is shifted and is blinking in the next position. So yes, the code is working as expected. Now we will print a complete word or array of characters. You can print also a sentence. So we'll uncomment this void display. It will take a character array W as a parameter, and the void main we will write here display, and we'll write here hello. So array of character is in double quotes because it's a string now. So we pass an array of character in this function. We'll uncomment this function. So now I'll explain you this function display. So when we pass a character array, it is in the W, and now we declare a variable I for the for loop. So initially I is equal to 0. It will check whether W of I is equal to null or not. Yes, it's not equal to null because W of I, which is W of 0, is H. The 0 position, H is at the 0 position here. This is a 0 position, this is 1, this is 2, okay, L is at the 2, and again L is at the 3rd, O is at the 4th. And what is here? Here there is nothing, there is null. So null is represented this way, /0. So W of 0 is not equal to null, so it will print H. Then it will print E, it will increment I. And W of 1, is it null? No, it's E. So it will print E, then it will print L, L, O all the way. So when W of I will become null, so this condition will be false and this will not get executed. So the word will be printed only till the last character in this way. So this for loop, this condition is very important. W of I is not equal to null, because it's checking every time before printing whether there is a character or not at that location. And in this way a complete word or a string of character is printed up till the last character. Now let's generate a hex file and upload this code. So you can see hello is getting printed on the display. The cursor is blinking on the next position. Suppose this sentence is greater than the 16 character. Hello world of the humans. This is an alien speaking to us. Hello world of the humans. So let's see what happens when we will upload this code. So this is the output, and you can see that the complete sentence is not getting printed. So what if we want the complete sentence? Either we can print it on the next row or we can keep it scrolling. So let's make it scrolling. So now let's modify this code to display scrolling message. So the first thing we need to do is we need to pass a command after clear in the LCD init function to display on cursor off, because we don't want the cursor to blink. And the next thing we will do is we need to call this function only once in the main. So for that I will declare a global variable int state, and I will make it 1 initially, and in the main I will check whether state is equal to 1. If it's 1, then I will call this function LCD init, which will run all these commands, and then I will make state is equal to 0. So it will call this function and it will make state is equal to 0. So next time when this loop repeats, this condition is false and this function will not get called. So it will be executed only once. So I will store the message in a variable unsigned char message. This is a character array, and this is my message. Computers are integrated in every system. So this message I want to be printed on LCD. So in the next line I will write display. I will call the display function. I will pass this message as an argument. So this display function will display this message on the LCD. It will print this message on the LCD only up till the 16th character. So this message is displayed on the LCD up till the 16th character, and for 1 second it will stay like that, and then the scrolling will start. Okay, so I want this message count. So I want the length of this character array. So I will modify this display function now to return me the length of the array. So here I will write int because the return type is now a count. Here also I will write int. I will declare a variable here, int c is equal to 0. So initially c is equal to 0, and it will increment every time it sees a character. And it will come out of this for loop. I will return c. So in this way this function is now modified to return the character length. So here also I will declare two variables, int I and int count. So int I is for the for loop for scrolling, and int count is the character length that is returned when we call the display function. Now I want this for loop to run till the last character only. So int I is equal to 0, I is less than count minus 16, I plus plus. So inside this for loop, I will give a delay of 500 milliseconds. This will determine the scrolling speed. So this command 0x18 will right shift the message by one cell. And here we want a delay of 1 second, because now this, after the 16 character, this much part is getting displayed on the LCD, and I want it to stay there for 1 second. Then I will write LCD clear. So this command will clear the LCD, and again this will repeat. So the message will be displayed, we'll wait for 1 second, then the scrolling will start, and again the LCD will be cleared. So yes, this was the code. Now let's generate the hex file. So yes, the scrolling message code is uploaded, and you can see this is the output. So the output is as expected, and the LCD is printing this message. So in this way this code works. Now let's proceed on to the 4-bit mode, where we only use 4 wires to display a message on the LCD, so you don't require all the 8 wires. So let's see the logic of the 4-bit mode. So now for the 4-bit mode we require only this 4 lines from D4 to D7, but in this circuit diagram D4 to D7 is connected from 2.4 to 2.7. So we need to disconnect all these wires and connect D4 to D7 from 2.0 to 2.3 like this, such that D4 is connected on 2.0, D5 on 2.1, D6 on 2.2, and D7 on 2.3. So I will disconnect the wires from D0 to D7. This is D4, which will be connected on 2.0. D5 will be connected on 2.1. D6 will be connected on 2.2. And D7 will be connected on 2.3. So the connections are done for the 4-bit mode. Before writing the program, I will explain you how the 4-bit logic works. So now let's understand the 4-bit mode, that is how to send data from a microcontroller port in such a way that LCD receives 8-bit data. So for that we need to understand how the data is put on the port, 8-bit data is put on the port. So for example, we have 0x21. So its binary representation is 0010 and 0001. So this is the LSB, which is on 2.0, this is on 2.1, this is on 2.2, this is on 2.3, 2.4, 2.5, 2.6, this is on 2.7. So in this way, this 8-bit data is on the port. This is called the lower nibble, this is the higher nibble. So in the 4-bit mode, we have only this 4 lines from 2.0 to 2.3. So the LCD is receiving only 1, it's not receiving 2. So it's receiving only the lower nibble. So how to send this to 1? So that's by putting the LCD in the 4-bit mode by sending the command 0x28, which will put the LCD in the 4-bit mode. So now the LCD will internally add the 2 lower nibbles. So first we need to send 0x02, so that the LCD will receive first the 2, then you have to send 0x01, then it will receive 1, and internally the LCD will add these 2 and it will receive 0x21. So now how to get 0x02 from 0x21? That's easy. All we have to do is right shift this data 0010, and you have to right shift this by 4, 1, 2, 3, 4, goes here, this goes here, and this all is 0. So in this way, this is a right shifted value which is 02. So we get 0x02 when we right shift this. So this can be a command or data depending on our function. So if the command is right shifted by 4 and then we put it on a port, okay, port 2, so data is our port 2. Then we need to send 0x01 on the port. So how to get 0x01 from 0x21? That's easy. All we have to do is AND this value by 0f. This is our 8-bit data. We have to AND it with 0f. F is all 1. 1 and 1 is 1. 0 and 1 is 0. This is also 0. This is 0. And this is all 0. So we get 0, 1. So first we right shift the command or data by 4 and send it to the port 2. Then we AND it with 0f and send it on port 2, one after the other. So now let's go to the programming part and see how it's done. This is a complete code for LCD in 4-bit mode. So the first change I've made is in the LCD init function. So I've replaced 0x with 0x28 just to put LCD in the 4-bit mode. So the next change I've made in the LCD command function. When it receives 8-bit data, it is right shifted by 4, it is put on the port, then RS is made 0, enable is given high to low pulse. Then the same lines are repeated, but this time the data is ANDed with 0x0f and it is put on the port. The same thing I am doing with the data function LCD data. So when it receives 8-bit data, it is right shifted by 4, it is put on the port, RS is made 1, enable is given high to low pulse, and the same lines are repeated, but this time the data is ANDed with 0x0f, it's put on the port, RS is made 1, enable is given high to low pulse. So yes, this was the complete code. Now let's build the hex file. So yes, the code is uploaded and you can see the output. It's the same as the 8-bit one. It should be the same because all we have done is I have modified it to the 4-bit version. And yes, this is the expected output. So this was a complete LCD tutorial. So in the next tutorial, we are going to see the timers. So like and subscribe to my channel. Thanks for watching.